September 1939. Britain declares war on Germany, and within hours U-Boat U-30 torpedoes the passenger liner Athenia, 250 miles off the Irish coast. 128 people die, including 28 Americans. It's a grim preview of what's coming. Grand Admiral Karl Donitz has 57 operational U-Boat, and he's already calculated exactly how to strangle Britain, sink 750,000 tons of Allied shipping every month. Do that and the island nation starves. The war effort collapses and Hitler wins without ever invading England. The math is brutally simple. Britain imports 68 million tons of supplies annually, everything from food to fuel to ammunition. Cut those supply lines, and Churchill's defiant speeches mean nothing. Donitz knows this, Churchill knows this, and for the first 18 months of war, Donitz is winning. By June 1940, France falls. Suddenly, German U-Boat aren't operating from distant German ports anymore. They've got bases at Brest, Lorient, Césaire, and La Rochelle, right on the Atlantic. The hunting grounds just moved 450 miles closer to the convoy routes. U-Boat commanders are now spending weeks on patrol instead of days. The killing accelerates. The numbers tell a horror story. In 1940 alone, U-Boats sink 471 Allied ships. 2.5 million tons of shipping sent to the bottom. That's one ship going down every 18 hours. In 1941 is worse. 432 ships in the first 6 months. Entire convoys are getting mauled. Convoy SC-7 loses 20 ships out of 35 in a single October night. Convoy HX-79 loses 12 ships the very next night. The Atlantic is becoming a graveyard. Here's what makes it so devastating. U-Boat are nearly invisible at night. A surface submarine sits low in the water. Just the conning tower breaks the surface, maybe 15 ft high. On a dark, stormy Atlantic night with 20 weighty swells and no moon, you can be 500 wide from a U-Boat and never see it. Meanwhile, the U-Boat commander is looking at you, a massive merchant ship silhouetted against the lighter horizon, belching smoke, completely exposed. Donitz perfects the Rudd tactic, the wolf pack. Instead of U-Boat hunting alone, they coordinate. One submarine spots a convoy and radios the position. Then 8, 10, sometimes 15 U-Boat converge like sharks. They wait until nightfall. Then they attack from multiple directions simultaneously, surfacing right in the middle of the convoy. Chaos erupts, merchant ships scatter. Destroyers race around trying to protect 40 ships spread across miles of ocean. And the U-Boat, they're already diving, already gone, melting back into the darkness. The escort destroyers have one tool, sonar. The British call it ASIC. It sends sound waves through the water and listens for codes. When it pings a submerged U-Boat, the destroyer races toward the contact and drops depth charges. 300 lb barrels of explosives set to detonate at specific depths. Sounds effective, right? Except there's a problem. A catastrophic, fatal problem that's killing Allied sailors by the thousands. And until one British officer refuses to accept the impossible, that problem will keep German U-Boat ruling the Atlantic, night after night after night. The depth charge attack follows a precise ritual, and every U-Boat commander knows it by heart because that knowledge keeps them alive. Here's what happens. The destroyer's sonar operator is tracking the submarine, calling out ranges 200, 1,000 yard, 800 wide. The destroyer's captain is calculating speed, depth, and distance. Everything hinges on that sonar contact. The pings are coming back strong and clear. They've got him. Then at around 200 YD, the destroyer captain gives the order, prepare to attack. The ship accelerates to maximum speed, maybe 25 knots, charging straight toward where the submarine should be. The depth charge crews are ready. Charges set to explode at the target's estimated depth. At exactly the right moment, the order comes. Release charges. The charges roll off the stern racks and heave off the side throwers. They splash into the water. The destroyer races away to avoid the blast. Then everyone waits for the underwater explosions. Those massive fountains of white water that hopefully mean a shattered U-Boat sinking to the bottom. But here's the killer. The moment the destroyer accelerates for the attack run, the sonar goes blind. Completely blind. The rushing water creates so much turbulence and noise that the sonar can't hear anything. It's like trying to listen for a whisper while standing next to a jet engine. From the moment the destroyer speeds up until well after the depth charges explode, somewhere between 60 and 90 seconds, the sonar operator is deaf. He has no idea where the submarine is. No idea if it's still heading straight or if it's turned or if it's diving deeper or rising toward the surface. 90 seconds doesn't sound like much, but underwater with a U-Boat commander who knows he has that window, it's an eternity. The moment a U-Boat commander hears those depth charges splashing above him, and yes, they can hear them, he knows exactly what to do. The destroyer is blind now. He immediately orders hard rudder. cranks the submarine into a tight turn, and changes depth. The depth charges were set to explode where he was, not where he's going to be. The explosions erupt 200, 300 wide away, close enough to rattle the hull and terrify the crew, but not close enough to kill them. By the time the destroyer's sonar comes back online, the U-boat could be anywhere in a circle with a 600-Y radius. The sonar starts pinging again, sweeping left and right, searching. Sometimes they pick up the contact again. Usually they don't. The submarine has slipped away into the dark Atlantic depths. The statistics are damning. Through 1941 and early 1942, destroyers are dropping thousands of depth charges. They're getting good sonar contacts. They're following textbook attack procedures, and they're achieving roughly a 4% kill rate. 4%. For every 25 depth charge attacks, 24 U-boat escape unharmed. Do the math on what that means. A destroyer carries maybe 50 depth charges. That's enough for perhaps 4 or 5 attacks before needing to resupply. If you're lucky, astronomically lucky, you might sink one U-boat. Probably you sink none. Meanwhile, that U-boat will sink a dozen merchant ships over the next 3 months before returning to base for resupply. The escorts are burning fuel, burning time, and burning explosives to achieve almost nothing. And worse, every experienced destroyer captain knows it. They can feel the U-boat slipping away in those blind 90 seconds. They can imagine the German commander laughing as he escapes. They can count the merchant ships that will die because this submarine survived. One of those frustrated captains is a British officer named Charles Goodeve, and he's about to refuse to accept that this is just how things have to be. Charles Goodeve isn't your typical Royal Navy officer. Born in 1904 in Winnipeg, Canada, he's a scientist first, a physical chemist who studied at the University of Manitoba, and then earned his doctorate at University College London. By 1940, he's working for the Department of Miscellaneous Weapons Development, which is exactly what it sounds like. A collection of scientists and engineers tasked with solving problems the regular military establishment has given up on. Good has been studying the depth charge problem obsessively. He's talked to dozens of destroyer captains. He's read every after-action report. He's analyzed the physics of underwater sound propagation. And he keeps coming back to the same maddening conclusion. The attack method guarantees failure. You have to go blind to deliver the weapon. It's like a fighter pilot having to close his eyes before pulling the trigger. In early 1940, he starts sketching a radical alternative. What if you didn't drop the charges behind the ship? What if you threw them forward instead ahead of the destroyer? While the sonar is still tracking while you still have contact. The submarine would still be exactly where your sonar says it is. No blind window, no escape opportunity. The idea seems simple enough, but the execution is nightmarish. You can't just toss a 300 Libby depth charge forward like a softball. The explosive force would need to carry the charge at least 200 wide ahead of the ship, far enough that the blast doesn't damage the destroyer itself. And that charge needs to arc through the air, hit the water at the right angle, sink to the right depth, and explode right on target, all while the ship is moving at speed through rolling Atlantic swells. Goodeve proposes building a multiple spigot mortar system. Picture 24 small mortars arranged in 4 rows of 6 mounted on the destroyers for deck. Each mortar fires a small projectile. Not a massive depth charge, but a compact 65 lb bomb with a contact fuse. The bombs fire in a tight pattern, creating a lethal carpet roughly 120 ft in diameter. If the U-boaties in that zone when the bombs arrive, at least one will make direct contact. And unlike depth charges that need to explode within 20 ft to be lethal, these contact bombs kill on touch. When Goodeve presents this to the Admiralty's Weapons Development Committee in late 1940, the reaction is brutally skeptical. Senior naval officers call it suicidal. Their concerns sound reasonable. You're firing explosive mortars from the bow, while sailors are working on deck. What happens if one misfires? What if the pattern is off and you damage your own ship? What if their coil throws the firing solutions off for the rest of the salvo? And perhaps most damning, you're replacing proven depth charges that can be dropped by the dozen with a contraption that fires just 24 small bombs. And if those 24 miss, you're defenseless. The Royal Navy has 150 years of tradition. The depth charge method is established doctrine tested in the First World War. Goodeve is proposing to throw that away based on theoretical physics and engineering drawings. One admiral reportedly tells him, "We've been sinking submarines with depth charges since 1916. Why would we risk a perfectly good destroyer on an untested weapon?" But Goodeve has an advantage. Britain is losing the Battle of the Atlantic. Merchant ships are sinking faster than the shipyards can replace them. In 1941, U-boat will sink over 4 million tons of shipping. Churchill will later write that the U-boat peril was the only thing that truly frightened him during the entire war. When you're drowning, you'll grab any lifeline, even one that looks impossible. By spring 1941, Goodeve gets grudging approval to build a prototype. The Admiralty isn't enthusiastic, but they authorize enough funding for testing. The weapon gets a code name during development: Hedgehog. The name comes from the way the 24 spigots bristle upward from the deck mount, looking like the spines on a hedgehog's back. It's every British piece of nomenclature, taking something deadly serious and giving it a name that sounds like a children's book character. The engineering team works out of HMS Vernon, the Royal Navy's torpedo and mining school in Portsmouth. They're starting essentially from scratch. Nobody's ever built a forward-throwing anti-submarine mortar before. Every component needs to be designed, tested, and redesigned. The spigots themselves are steel tubes, each one angled carefully to ensure the spread pattern. The projectiles, officially called bombs, not depth charges, airy streamlined teardrop shapes, weighing 65 lb, with 35 lb of that being Torpex explosive. Torpex is newer than TNT, roughly 50% more powerful, meaning these small bombs pack a devastating punch despite their size. The contact fuse is perhaps the most critical innovation. Traditional depth charges use pressure-activated fuses set to explode at predetermined depths, but Hedgehog bombs use impact fuses. They only explode if they physically strike something solid like a submarine hull. If they miss, they sink harmlessly to the bottom without detonating. This seems like a disadvantage until you realize the tactical brilliance. Silence means you missed. An explosion means you hit. The crew instantly knows whether the attack succeeded without waiting for debris or oil slicks to surface. The firing mechanism uses cordite charges to launch each bomb. When triggered, all 24 projectiles fire in a rapid sequence over about 5 seconds, staggered just enough to avoid interfering with each other in flight. They arc forward in apperset elliptical pattern, landing roughly 250 yards ahead of the ship. The entire spread hits the water within a 120 ft diameter circle. If the sonar solution is accurate, the U-boat is in the center of that circle when the bombs arrive. Testing begins in June 1941. They fire at stationary targets first, checking the pattern dispersion. Then they graduate to moving targets, retired submarines acting as practice targets, making evasive maneuvers while Hedgehog-equipped vessels attack. The early results are promising. The forward-throwing concept works. The bombs sink quickly to depth. The contact fuses prove reliable, but there are problems. The recoil is more violent than predicted. The first test firing actually cracks the deck plates on the test vessel. Engineers have to reinforce the mounting structure, adding steel supports that distribute the force across a wider area of the deck. Then there's the accuracy problem. Hitting a submarine-sized target at 250 yards while your ship is rolling in heavy seas turns out to be considerably harder than hitting static targets in calm harbors. The aiming system needs refinement, better gyroscopic stabilization to account for the ship's motion, and there's crew training. Sailors are comfortable with depth charges. You roll them off racks. Simple. Hedgehog requires precise timing, coordination between the sonar operator and the weapon crew, and constant maintenance of the firing mechanism. The cordite charges have to stay dry. The spigots need cleaning. The electrical firing circuit needs regular testing. It's more complex, more finicky, more demanding. By September 1941, the first operational Hedgehog systems are being installed on convoy escorts. HMS Orcus, a Flower-class corvette, gets one of the first installations. The crew is skeptical. Most of them would rather have extra depth charges. But orders are orders, and they're heading back into the Atlantic, where U-boat are still sinking 3 ships every day. Within weeks, Orcus will prove that impossible can become inevitable. The convoy is designated SC-48, steaming northeast from Sydney, Nova Scotia toward Liverpool. 50 merchant ships loaded with timber, grain, steel, and aviation fuel. It's October 1941 and the autumn North Atlantic is showing its teeth. 30-foot swells, bitter wind, visibility dropping as fog banks roll in. HMS Orcus, a corvette barely 200 ft long, is one of 8 escorts shepherding these lumbering cargo ships across 2,000 amateurs of water that German U-boat consider their private hunting ground. Lieutenant Commander R.C. Bohl commands Orcus. He's been briefed on the Hedgehog system bolted to his foredeck. He's supervised the crew training, but he's also a realist. In 18 months of convoy duty, he's made 9 depth charge attacks on confirmed sonar contacts. 9 attacks, 0 confirmed kills. The U-bot always slip away in those blind seconds, so when the sonar operator calls out a contact on the afternoon of October 15th, Boyle's expectations are measured. Contact bearing 270. Range 1400 widadu. The distinctive echo pattern is unmistakable. Submarine submerged, moving slowly, probably stalking the convoy, waiting for nightfall to attack on the surface. This is the moment. The U-bot doesn't know it's been detected yet. Boyle has the initiative. Come to 270. Maintain sonar contact. Prepare Hedgehog for firing. The crew moves quickly. On traditional attacks, they'd be prepping depth charge racks. Now they're checking the firing circuits on something most of them still don't quite trust. The ship turns toward the target. The sonar operator calls ranges. 200 wide, 1000 wide, 800 wide. Here's where everything is different. In a depth charge attack, Boyle would be accelerating now, going blind, hoping the U-bot stays on course. Instead, Orcus maintains steady speed. The sonar keeps pinging. The contact is sharp, clean, constant. 600 yards, 500 YD, 400 wid. At 300 YD, Boyle gives the order. Fire Hedgehog. The electrical triggers engage. The cordite charges ignite. In 5 seconds, 24 bombs arc forward off the bow, trailing smoke. They look almost lazy as they sail through the air, small dark shapes against the gray sky. Then they hit the water in a spreading pattern, creating 24 distinct splashes roughly 250 yards ahead of the ship. The sonar operator is still tracking, still calling the range to the submarine. Contact steady at 270, 280 YD, depth 150 FT. The bombs are sinking now, invisible beneath the surface, dropping through the dark water at roughly 25 FT per second. 6 seconds after impact, 7 seconds, 8. Then the ocean erupts. Not the single massive fountain of a depth charge, but 3 sharp explosions in rapid succession. Wham, wham, wham. 3 of the 24 bombs have found their target. The contact fuses work exactly as designed. Somewhere beneath the surface, 3 35 lb Torpex charges have just punched through a pressure hull. The sonar operator's voice changes. Contact breaking up. Multiple echoes, debris rising. Within 2 minutes, the evidence surfaces. Oil thick and black spreading across the water. Wooden debris, a life jacket, papers, a leather boot, and then conclusively an expanding air bubble breaking the surface. The unmistakable signature of a shattered submarine's last breath escaping from a ruptured hull. The crew on Orcus isolent for a moment. Then someone starts cheering. They got him. No blind attack, no hoping, no watching the bastard slip away. They tracked him the entire time and put bombs right on target. For the first time in this war, sonar and weapon worked as one system. The U-bot is later identified as U-56844. German sailors die in those explosions. It's not a clean death. War never is. But it's proof. Hedgehog works. News of Orcus's kill travels fast through the Royal Navy. Within weeks, every anti-submarine warfare officer in the Atlantic Fleet is demanding Hedgehog installations. The Admiralty's skepticism evaporates. By December 1941, production orders are flooding to manufacturers. The weapon that was suicidal 6 months ago is now the most requested equipment in the fleet. The British firm Fairfield Shipbuilding gets the primary contract. They're already building corvettes and destroyers, so adding Hedgehog production to their Glasgow facilities makes logistical sense. Each complete system, the mounting frame, 24 spigots, firing mechanism, and initial bomb load, takes roughly 120 man-hours to manufacture. By early 1942, they're producing 15 systems per week. That's 60 per month. Everyone goes straight to a convoy escort being fitted out or refitted. The Americans are watching closely. In January 1942, just weeks after Pearl Harbor, U-bot arrive off the American East Coast for Operation Drumbeat. They're sinking tankers with inside of Miami, freighters off Cape Hatteras, cargo ships outside New York Harbor. The U.S. Navy, unprepared for coastal warfare, watches helplessly as 609 ships go down in American waters during 1942. The U.S. needs Hedgehog, and they need it immediately. Lend-lease agreements expedite the technology transfer. By April 1942, American factories are producing their own version. The U.S. model has minor modifications, different mounting brackets to fit American destroyer classes, slightly different electrical systems, but the core concept is identical. Production ramps up fast. By the end of 1942, U.S. shipyards are installing Hedgehog on every new destroyer and destroyer escort coming down the ways. Older vessels get retrofits during regular maintenance cycles. The statistics start shifting in early 1943, and the change is dramatic. Destroyers using conventional depth charges are still achieving roughly 57% kill rates per attack. Hedgehog-equipped vessels, they're hitting 25–30%. That's not a marginal improvement. That's a revolution. For every 4 Hedgehog attacks on confirmed contacts, 1 U-bodies. Compare that to the old odds where you needed 15–20 attacks to get a kill. The math cascades through the entire Atlantic battle. Admiral Donuts had calculated he needed 300 operational U-bot to cut Britain's supply lines. By January 1943, he has 212. Not enough, but getting close. Then the losses start accelerating. In March 1943, U-bot sinks 127,000 tons of Allied shipping. But Germany loses 15 U-bot that month. In April, 15 more. In May, the catastrophe. 41 U-bot sunk in 1 month. 41. Donuts calls it Black May. Hedgehog isn't the only factor. Improved radar, long-range aircraft, code ring, and escort carriers all contribute. But destroyer captains filing after action reports are clear. Hedgehog attacks succeed where depth charge attacks fail. HMS Lagan sinks U-608 with Hedgehog in February. HMS Swallow gets U-432 in March. USS Braunstein kills U-79 in May. The kills keep coming. By July 1943, over 300 Allied warships carry Hedgehog systems. Every convoy escort group has at least 2 Hedgehog-equipped vessels. The tactical doctrine evolves. When sonar gets a contact, the Hedgehog ships take lead on the attack while conventional destroyers provide backup and prevent escape. The U-bot are being systematically hunted down. The production keeps accelerating. British factories produce over 6,000 Hedgehog bombs per month by mid-1943. American factories add another 4,000 per month. That's 120,000 bombs. Annually. Enough to supply hundreds of ships making thousands of attacks. The logistical chain works smoothly now. Escort vessels rearm at bases in Iceland, Newfoundland, Londonderry, Liverpool. A ship can fire its entire 24-round load, return to port, reload, and be back on convoy duty within 48 hours. The Battle of the Atlantic is turning slowly, painfully, but definitively, and every U-bot commander knows why. The darkness that protected them is gone. U-bot commanders start noticing the change in late 1942, but they don't understand what's happening. Corvette and Capitan Herbert Schneider, commanding U-522, writes in his war diary, after surviving an attack in January 1943, new weapon, multiple small explosions, very precise, no warning splashes overhead. We took evasive action, but bombs followed our position exactly, hull damage returning to base. That phrase keeps appearing in German after-action reports. No warning splashes. With depth charges, crews could hear them hitting the water above. That sound gave them precious seconds. Hard rudder, change depth, run silent. But with Hedgehog, there's no warning. The bombs are contact fused. If you hear them, they've missed. If they hit, you're already dead. There's no in-between. Dunit reads these reports with growing alarm. By March 1943, he's getting descriptions from multiple commanders about a new forward-throwing weapon that fires while the destroyer is still tracking. His intelligence staff pieces together the details from survivor interrogations and salvaged equipment. They identify it as a spigot mortar system, British-designed, now in widespread use. The tactical problem is existential. Every U-bot doctrine is built around that blind window during depth charge attacks. The standard evasion procedure memorized by every commander is now worthless. You can't evade what you can't hear coming, and you can't exploit a blind spot that no longer exists. Thay destroyers are tracking continuously right through their attacks. Donuts orders immediate tactical changes. Haubitar instructed to go deeper when detected beyond 600 FT or if the boat can handle it. The theory is that deeper depths give more time to maneuver after detecting the sonar pings, but it's a desperate measure. Diving deep means slower speed, less maneuverability, and crushing pressure that makes the hull groan, and the Hedgehog bombs sink fast. Going deep just means you're deeper when they find you. Some commanders try aggressive counter tactics. When detected, instead of diving and running, they turn toward the destroyer and fire torpedoes, trying to force the escort to break off the attack. It works exactly once. HMS Harvester takes a torpedo hit during a Hedgehog attack in March 1943 and sinks, but the U-bot U-44 gets depth charged by another escort minutes later. Trading a submarine for a destroyer isn't sustainable math. When Germany is building 20 U-bot a month and Britain is building 40 escorts, the psychological impact is crushing German morale. U-bot crews used to feel like hunters, invisible wolves picking off merchant ships at night. By mid-1943, they feel like prey. Every patrol becomes a nightmare. Every sonar ping could be the last sound you hear. The veterans who survived 1940 and 1941, the ones who sank dozens of ships, are being killed by escorts they can't escape. Oberberleutnant Peter Kamer, commanding U-333, later writes, "We were no longer the hunters. We were rabbits, and the destroyers had become foxes who could see in the dark." The casualty rates tell the story. In 1942, a U-boat crew had roughly a 10% chance of dying per patrol. By late 1943, it's over 30%. Young submariners are doing math. The average U-boat makes 4 patrols before being sunk. If you're assigned to U-boat, you're probably going to die. Not might die, probably will die. Morale in the U-boat service, once elite and prideful, collapses. Donuts keep sending them out anyway. He has no choice. Hitler demands the Atlantic campaign continue. But by September 1943, the U-boat are losing. They're sinking fewer Allied ships while suffering higher losses themselves. The darkness that once protected them is now just water where they drown. The numbers from May 1943 tell you everything you need to know about where the battle is headed. Allied shipping losses 264,000 tons. U-boat losses 41 submarines. That's the crossover point. For the first time in the war, Germany is losing U-boat faster than the shipyards can replace them, while Allied merchant ship production is vastly outpacing losses. The equations that Donuts calculated, in 1939 sink 750,000 tons per month and Britain falls, are no longer working. He's not even reaching half that tonnage, and it's costing him the entire U-boat fleet. By the end of 1943, Hedgehog-equipped vessels have sunk 47 confirmed U-boat. That's out of roughly 240 total U-boat kills for the year, meaning Hedgehog accounts for nearly 20% of all U-boat losses, despite being installed on less than 15% of Allied anti-submarine vessels. The kill-per-attack ratio is even more telling. Hedgehog attacks exceed 24% of the time compared to 7% for conventional depth charge attacks. When you're hunting submarines, that difference means everything. But here's the larger strategic picture that Churchill and Roosevelt are watching. Britain isn't starving. The convoys are getting through. In 1942, 7.8 million tons of supplies reached Britain. In 1943, despite continued U-boat operations, that number rises to 13.4 million tons. The supplies keep flowing, which means British factories keep producing tanks, aircraft, and ammunition. American troops and equipment keep arriving. The buildup for invading Europe becomes possible. D-Day, June 6, 1944, requires moving 156,000 troops across the English Channel, supported by 6,239 naval vessels. But before that invasion even launches, it requires 2 years of logistical buildup. Every tank, every truck, every artillery piece, every gallon of fuel, every round of ammunition has to cross the Atlantic first. Operation Overlord consumes 2.5 million tons of supplies in the first month alone. None of that happens if U-boat are still sinking 600,000 tons of shipping monthly. Hedgehog doesn't invade Normandy, but it protects the ships that make Normandy possible. The final statistics from the Battle of the Atlantic span 1939 to 1945. Total Allied merchant ships lost, 3,500 ships totaling 14.5 million tons. Total U-boat lost 783. Of those 783 U-boat, historians credit Hedgehog-equipped vessels with sinking at least 82 confirmed kills, possibly over 100, when including shared kills and uncertain attributions. 82 doesn't sound overwhelming until you remember that each of those U-boat, had it survived, would have sunk an average of 105 merchant ships over its operational lifetime. That's 820 to 1,230 merchant ships that stayed afloat. At 100 sailors per merchant ship on average, that's $82,000 to 123,000 Allied merchant seamen who lived instead of drowning in the North Atlantic. Charles Goodeve receives a knighthood in 1946 for his wartime contributions. He never serves on a destroyer, never hunts a U-boat personally, never fires a weapon in combat. But his refusal to accept that the blind spot problem was unsolvable saves more lives than most combat commanders. Here's what makes the Hedgehog story remarkable. It wasn't exotic technology. It wasn't radar or atomic science or code reeking. It was 24 steel tubes firing 65 lb bombs 250 yards forward. Simple physics, basic engineering, and one core insight. Keep tracking while you attack. But that simple innovation multiplied across hundreds of ships and thousands of attacks helped win the Battle of the Atlantic. One sailor's impossible discovery became the reason destroyers could hunt in total darkness. And that changed everything.